Hi, if you have a balloon or a set of balloons and you try to get a toothpick or a nail or needle, something pointy to try to poke it, guess what would happen? The answer is very simple. It will pop. Very easily. Now, instead of having only one pointy object like the toothpick or nail, what if I have many of them, for example like 40, 50 of them, pushing, poking the balloon at the same time like the nail bed that we have here? Make a guess. Let's check the result in slow motion. Wow, he's pushing really hard. You can see the deformation. But the balloon is still not pop. Oh, finally. Oh. Okay, so based on what you have observed between one nail and many nails, can you try to give us a suggestion and explanation on why it is so much harder to pop a balloon with the nail bed? Pause the video and try to put down the explanation yourself.
A few moments later.
Before I give you my explanation, I would like to give you some more hint. So if you go back to the previous page, which I talk about the pressure with solid, then you'll find out there's an equation related to pressure, force, and area. So now, try to understand this equation. You may want to read the textbook or search on Google and think about how this equation can help to explain the question just now. Pause the video and try to update your answer.
A few moments later.
Alright, so here is my explanation. So first of all, a balloon can only be popped when reaching a certain limit of pressure. So if you reach that pressure, that is the limit of the balloon, depending of course the elasticity of the balloon, the material of the balloon itself. Of course, if you have different size, different material of the balloon, this particular limit will be different. But the most important thing is it depends on the pressure, not actually the force. And so by the equation that we just mentioned, P pressure equal to force over area, then you can think about when you have only one nail and having many nails in the nail bed, then you'll find out the area. If you change from one nail to many nail beds, then the area actually increase because you have many more. You have like 40 or 50 more, and therefore area is going to be multiplied by that many amount, right? Because when we talk about the area, we are talking about the very little pointy area at the very top of the nail. And so it was very tiny, but if you can multiply that with 40 or 50, it's still many more, right, than only one nail. So according to this mathematical relationship, then you will find out if the pressure is actually a fixed number because we are using the same balloon. Let's just say this is going to be unchanged, so I put a cross here. Then you have to have applied a greater force in order to reach the same pressure, right? If you look at the mathematical relationship. So whenever you try to explain something in physics, this is something that you can do, which I just demonstrated. And now let's try to put this into words. So we can say when we change, okay, let's not use the first person voice. Let's use a passive voice. So when it was changed from one nail to many nails, the surface area was significantly increased. Okay, and then in order to reach the same pressure, which is the so-called popping pressure, the pressure to pop, a greater force would be required. Okay, so that is the explanation why when you have a nail bed, it actually is harder to pop. And in the science museum, usually, at least the one in Hong Kong, there was also a nail bed where you can lie on it. It looks quite daunting, like it looks like, oh, it's very dangerous and harmful. It's actually okay, all right, as long as you don't put just one finger to push against one nail, all right. If you just lie slowly, carefully on top of it, it's actually not going to harm you. Now let's go back and closely examine this equation and the concept again. This is called the pressure with solid because later on in the next video or soon we'll talk about the pressure with liquid and gas too, and they somehow behave differently, and that's why it's important to identify whether we are dealing with solid or liquid or gas. So here again, the equation is pressure equal to force over area, and the unit is going to be Pascal. Pascal is a name of a scientist, and this is something that he find out and therefore named after him, just like Isaac Newton. And here there is a question that may help you in the exam. In case you don't remember Pascal, which is the unit of the pressure, then there's actually an alternative that you can do. So by applying what you have been learning in my lessons so far, can you try to think about what is the other alternative of the unit for pressure? Pause the video now.
A few moments later.
Alright, the answer is that if you try to look at the equation again, we have P equals to F over A if the unit of pressure will equal to unit of F over A, and pressure unit is obviously Pascal, PA, by the way, capital letter P, because again it is a name. So the unit will be equivalent to force, which is Newton, and divide by area, which is meter square. Okay, so this is the alternative which you can write down here. Or if you like to, you can also write the mathematical equivalent, which is Newton meter negative 2. Okay, so this will be the alternative in case you don't remember the unit Pascal. The other idea that this question also reminds you is that whenever you try to calculate pressure, and if you want to express the answer in Pascal, then you have to make sure that the force is really in Newton and the area is really in meter. Okay, especially the area, because sometimes the question may ask you or provide you the information that is in cm or mm again, and then maybe you can somehow calculate the area in cm square or millimeter square also, but then this is not meter square. Okay, and so in that case you can either do the conversion, changing the cm square or millimeter square back to meter square, which is not quite easy, to be honest. If you don't have to, then probably you don't want to do that. The other alternative is to simply express the answer in terms of the corresponding unit. So that is to say, if they are giving you cm square instead of meter square, then your answer, after you substitute whatever numbers you get, should be in Newton per cm square in this case. Okay, and that means you cannot say it is in Pascal because it doesn't really equal to Pascal at all. Take a look here. So as you can see, it cannot really move and it is terrible. And magically, what you can do to deal with this situation is if you can have a strap and you can strap the long wood stick together with the wheel, it can actually help you to resolve this issue. This is a very common technique which you can help you in the very emergent situation. So let's see how it works. Ooh. Okay, try to observe and later on I will ask you to explain. Come on. Come on, let's go. Alright, so you can see there's a bit of movement. It's improving. And here we go, right? It start moving again. So this is a very common method, and maybe in your life you'll be able to use it. So now get yourself a time to write down your explanation on the workbook about why this is helpful. Pause the video now.
A few moments later.
Alright, so here is my explanation. First of all, the reason why the car would get stuck in the snow or mud is because the tire is or was exerting too high pressure to the snow. You may ask, why do I know that? Think about this. If you have a knife like this one, then obviously you only use this side to cut whatever you want to cut other than the back, because if you look at the edge, alright, this contact area is much more narrow and therefore smaller compared to the back, which is much more bigger. Okay, so if you think about the equation just now, when we talk about pressure equals to force over area, since the area is so small, so it's very easy to cut off anything. If you ever visited a city which is snowing and you are on a car trip, maybe with your family, then you realize when you try to rent a car, those cars' wheel will be installed with this kind of chain. These are called the snow chains. And the idea is the same. When you get the chains on the wheel itself, it increases the area, and therefore the pressure will be reduced, and also it increases the so-called grip of the wheel, and therefore it's easier to get the friction, continuously adding on your car instead of skiing. So it will help you and keep you safe. So in this video, we have learned about the idea of pressure and the equation P equals to F over A to explain different case studies, different scenarios in our life. Can you think of more of these examples other than the one that I suggested? Put the examples in the comment section below. In the next video, we'll talk about the pressure against the liquid and also gas. I'll see you again in the next video. Bye!